Okay, now we're going to talk about position, velocity, and acceleration once again, and see how we can actually use integrals to be able to tell us some pretty valuable information. So let's say the problem says there's an object moving along a line, and this is the acceleration path. We talked about acceleration, velocity, and position before, that velocity is the derivative of position, and acceleration is the derivative of velocity. So if acceleration, a of t, equals 2t minus 7, meaning that every second the acceleration is going up by 2, and that it started at -7. Okay, that's just plotting the line and seeing that. So let's say, what if the question said find the velocity if the find the velocity equation if the initial velocity is 12 units, so it'll be 12 feet per second. So what we have to do is say, well, v of t, and you may want to show this work, equals the derivative of a of t dt. And this would be, well, we'll do t squared, both up 1. 2 over 2 is just 1, so it'll be the t squared minus 7t. And that's the velocity equation. But don't forget about the plus c at the end. However, this equation is not complete if we have this plus c at the end. Luckily, the problem told us that the original velocity is 12 feet per second in this case, so we could just think, well, v of 0 equals 12, so 12 equals 0 squared minus 7 times 0 plus c, then c is going to equal 12. And most of the time in this equation, it's just the initial velocity is going to be this. The question won't always give you initial velocity. It might say velocity after 2 seconds or something, but then you just plug in 2 here and solve for c. And so we get that the velocity equation is t squared minus 7t plus 12. Right? So the question actually asks, I didn't want to overcomplicate it first, so the question actually asks, what is the velocity after 5 seconds if the initial velocity is 12 feet per second? Well, then all you have to do then is do v of 5. 5 seconds, which would be 5 squared, 25, minus 7, 5, plus 12, which I believe equals 2, doesn't it? Let me just check that. Yes, 2 feet per second. I just did that in my head. Okay. So then the question is going to go on and ask, when is the object at rest? Well, an object is at rest if it's not moving. If it's not moving, then the velocity must be 0. So what we'll do in this case is I'm going to erase this, but I'll keep the equation up. What we're going to do in this case is say that this equals 0. 0 equals the velocity equation, which is t squared minus 7t plus 12. Which factors? So it would be t minus 3 and t minus 4 equals 0. So the object is at rest at time equals 3 seconds and 4 seconds. Then the last thing it says is find the equation for the position of the line, aka p of t, if the initial position is 3 feet in the positive direction, which is probably right. Well, we'll do the same thing again. P of t for position equals the antiderivative of v of t dt. We're basically just going to do this again. It's going to be up 1, so it'll be t cubed, but it'll be 1/3 in front to cancel out the power rule, minus 7 over 2 t squared, and you get used to doing this in your head, plus 12t plus c. And if it says the initial position is 3 feet, then once again we're just going to say p of 0 equals 3. So 3 equals 0 cubed minus 0 squared plus 0 plus c, then c equals 3. And therefore, the position equation p of t equals 1/3 t cubed. I feel like I wrote this like 3 times. Minus 7 over 2t squared plus 12t plus 3. And that's how the antiderivatives apply to position, velocity, and acceleration, and how you can find the equations using that.